Okay, so before we've looked at the Haber process, the other one you need to know for triple science is the contact process. So today in this video, we're going to look at the uses of sulfuric acid. We're going to describe the manufacture of sulfuric acid. So how do we make sulfuric acid? And then we're going to look at some of the disadvantages of this process. So first off, and there are loads of them, pick the ones that you think you are going to remember, okay? So we use them to manufacture fertilizer, to manufacture paint. We use them in electrolytes. We use them to make synthetic fibres, making pesticides, and they are in our detergents, okay? So sulfuric acid is all around us. Pick a couple because it often come up as a use and remember them. What are the uses of sulfuric acid that you are going to remember? Okay, so the process of making sulfuric acid is a 3-stage process, okay? This little diagram is in your class notebook, but if you're not using class notebook, you can draw it out, okay? It's not complicated, you just need 3 boxes and what's going in and out, okay? So we've got sulfuric acid and dry air going in. That makes sulfur dioxide and oxygen. Then that sulfur dioxide undergoes a process here with the catalyst and the degrees. You need to remember it's a vanadium oxide catalyst and it's 450 degrees. That then makes sulfur trioxide. And then this is a whole process here to make sure that it doesn't explode to make the sulfuric acid. So we're going to go through each stage. This is known as the contact process. We've already looked at the Haber process, which is how you make ammonia. You need to be able to comment on both. You need to be able to comment. Okay, so the first stage, we've just talked about this. Stage 1, okay, in the furnace, molten sulfur, so that means melted. Okay, melted sulfur is burned in dry air to produce sulfur dioxide, okay? This gas is purified and cooled, okay? So sulfur plus oxygen, because oxygen is in a pair, makes sulfur dioxide, okay? That's why we're talking about dry air that's kind of had any water vapor removed from it, and we use that as our source of oxygen. So that is stage 1. Stage 2 then. Stage 2, in the converter, sulfur dioxide and excess oxygen gas are passed over a few plates of vanadium oxide at 450 degrees, okay? This produces something known as sulfur trioxide. And again, you've got the equation, sulfur dioxide plus O2 gives you sulfur trioxide, okay? Another bit of stage 2 then, moving on, okay? 99.5% of the sulfur dioxide is converted to sulfur trioxide through a reversible process, okay? So this is reversible. You can go back and make the sulfur dioxide if you need it, okay? But about 99.5% is completely converted. So in the final stage, it's a little bit different. So what happens is the sulfur trioxide gets passed into some sulfuric acid, okay, and that creates something known as an oleum, okay, H2SO7, okay. That oleum is then mixed with water to create sulfuric acid, okay. So you need a certain amount of sulfuric acid to make sulfuric acid, which is a little bit confusing. So you mix sulfuric acid with SO3, which is sulfur trioxide. That makes this oleum, okay? This oleum is then mixed with water to make sulfuric acid. Now, you might be thinking, why do you add sulfur trioxide to sulfuric acid? Why don't you just add sulfur trioxide directly to the water to make H2SO4? Okay, the reason we do this, okay, it would be highly explosive. So we add sulfur trioxide to sulfuric acid, that makes the oleum, and then we add in the water. We couldn't directly add the water to the sulfur trioxide because it reacts too violently with the water, okay? It would produce a lot of heat and a large cloud of sulfuric acid, known as a H2SO4 mist. This mist is corrosive, pollutes the air, and is difficult to condense. So what we do is we mix the sulfur trioxide with sulfuric acid. That makes the oleum, and then we add the water, okay? We cannot skip that step, otherwise it would be really explosive and we would create this sulfuric acid mist. Okay. So a couple of questions to think about. Have a look at them, and then we'll go through the answers in a minute. So press pause, have a look at them, and we'll see what you can remember. Okay, so what we have most probably learnt about today in another bit of this lesson when we did reversible reactions. So excess air, increased concentration of oxygen is used. Explain what this does to the position of the equilibrium and the yields of sulfur dioxide and sulfur trioxide. Explain your answer. Okay, so when you increase the amount of the concentration on this side, it shifts the reaction towards the products. Okay, so it would increase the yield of this one, sulfur trioxide, but it would decrease the yield of sulfur dioxide because that's on the reactant side. So increasing the concentration is going to shift the equilibrium towards the products. So it's going to shift the equilibrium, just put EQ, towards the products. Okay, the reaction is exothermic. Would a higher or lower temperature increase the yield of sulfuric trioxide? Explain your answer. So, because it is exothermic, it favours a lower temperature. Okay, it favours a lower temperature because with a higher temperature, it will shift the equilibrium towards the reactants, which we don't want. Okay, so actually exothermic reactions like this to go towards the products favour a lower temperature. Okay, a catalyst is added. What is a catalyst? What is this catalyst called, and what does it do to the position of the equilibrium? Okay, so it's called the vanadium 5 oxide. You need to remember that. Okay, catalysts have no effect on equilibrium. Okay, they're not going to shift the equilibrium themselves. Okay, but because they lower activation energy, they will naturally shift it towards the products because more of the reactants are going to react. Okay, so talked a little bit about the issues with sulfur trioxide, but if you can remember from last year, sulfur dioxide is also a massive issue. Okay, so sulfur dioxide can infect a human in quite a lot of ways. It can cause coughing, chest pain, shortness of breath, lung disease. Okay, but the big thing is it can cause acid rain. Okay, so it can cause acid rain. And acid rain can do a couple of things, okay? It can make lakes and rivers become acidic and a threat to aquatic life, okay? It can lower the pH value of the water. It can lower the pH value of the soil, so salts and come out the top, roots can be destroyed, and plants can die of malnutrition and diseases, okay? Then within humans, it can cause us to have respiratory problems. It can also corrode buildings and metal structures. So, last little thing you need to know about sulfuric acid, okay, it is an extremely large dehydrating agent, okay? Which means it's really good at removing water from substances. The two different chemical reactions you need to know is one, when using sulfuric acid to remove water from hydrated copper sulfate, that will leave behind a white powder known as anhydrous, so without water, copper sulfate, and you need to know the colour change, okay? So when it's hydrated, it's blue in colour. When it's not hydrated, it's white in colour. The other one that you have to know, now normally if we were in the classroom, so normally we would do this in the classroom, but obviously we can't. So, concentrated sulfuric acid will remove water molecules from glucose. Okay, so that's just the chemical symbol for glucose, which will leave behind pure carbon. Okay, it's highly exothermic, so gives off a lot of heat and produces a lot of steam, which forces the carbon upwards into a reaction vessel. The carbon looks like a black snake growing out of the reaction container. I will put a video on the OneNote for you to see. Normally, I'd show you in the classroom, but there's not a lot I can do. It only happens with concentrated sulfuric acid. You can see in this example, if it's dilute, so with water, it doesn't happen. It can be any type of sugar, glucose. Okay.